Hello and good afternoon. My name is Manfred Zoermer. I'm the product manager for molecular filtration within Mann und Hummel, Life Science and Environment Group. My today's topic is to talk about damage control of corrosive gases in data centers. Just to give a quick introduction and overview, usually data centers have utilize HVAC-based cooling, and they do ignore the environmental air pollution when applying this. I've been to around about 60 to 70 data centers on industrial or in free applications actually, there's been an electronic regulation called RoHS that was implemented between 2002 and 2006. And actually, this is an unholy alliance. HVAC, cooling, data centers, and placement of data centers when it comes to air pollution. If you look at the way that hardware, electronics is made, you're looking at impacts of copper and silver corrosion on print circuit boards and in microchip connections. There is actually a paper out there, and there are working groups that have worked on that back in the early 2000s to take care of this. However, it's never been really adapted, and that is sort of a thing that actually is now, since data centers, the business has grown so fast, it's actually now getting a kickback because we're getting more and more corrosion-related issues because of copper and silver corrosion. For whom is this presentation basically, or where is it dedicated to? Data center planners, owners, facility engineers, operators, and facility management services. The situation, if you look at where do I place a data center, a lot of the data centers, and we're not just talking hyperscalers or huge operations, we're also talking on-site data centers, things that where you have a lot of PLC control of chemical engineering, of process engineering. You are looking at polluted air, and polluted air is not only industrial pollution, but it's also pollution by heating, like fossil fuel, burning fossil fuel, but also if you have agriculture around, it's your farmer spreading manure around, basically on fields that surround your data center. So if you're pulling in fresh air, you are pulling in a lot of the air that's coming from the manure, and the manure, as being processed in biogas reactors, contains a lot of sulfurous gases, a lot of nitrogen-based gases, being amines, ammonia itself, but also other compounds that heavily attack either silver immersion welds or copper wires on print circuit boards. The solution is basically there. It's always been described. It's been in a ASHRAE paper. If you look at the components that are basically being attacked, is before 2002, and then when RoHS became fully implemented in 2006, solder was lead tin solder, and lead tin solder was not so much prone to attack against sulfur. It was a very stable compound, very low reactivity, and you had less problems. You had your problems with your copper on print circuit boards, but it wasn't that the solder itself became an issue. Today, with a lot of the interconnect metals being nickel, palladium, and also other metals that are being deposited, you find yourself that these metals are getters for sulfur compounds, and they start to form brittle compounds that actually destroy the print circuit boards and destroy the semiconductor itself. This is well documented, well described. There's numerous papers on that. And specifically, if you look at the work group that's been formed of semiconductor manufacturers, because all of them, they got warranty claims, they got issues with a lot of the replacement systems, which again got destroyed due to airborne corrosion. They basically formed a work group together with ASHRAE to document that and to develop countermeasures that are easy to implement in HVAC systems. But honestly, I never see them. Pictures of the corrosion you can basically see here. This is stuff that welds. Either you get pitting, you get basically formation of crystals that actually are electrically conductive, and these form interconnects between the different lines. You get creep corrosion, and this is something that if you go into a data center, you have a system that's installed for a year or two, and there's been farmers spreading fertilizer, spreading manure. You can basically take the system out, pull out the print circuit board, and you can see the black dust being formed on top of the print circuit board. You can basically, just wipe it off, and you can see the destroyed print circuit boards. But the corrosion is not only limited to the electronics themselves, but also to the power supply. If you look at the power supplies, the electronic parts damage isn't really that what counts, because you can either, with 30% growth year on year, you get free replacements, you need to replace that stuff anyways. It doesn't really matter. So it's just a cost that's just been implemented in the operation of a data center. What's more of an issue are the things of data center downtime, because you're talking damages of between $100,000 up to $10 million per hour, with downtimes ranging from 48 to 72 hours until your systems are totally back up again. So that's massive. You have fire hazards that basically, and I'm going to show this little video. It's not for the faint-hearted, I have to say. So if you're a little bit emotional, something nasty is happening in there. I can tell you that already. You have fire hazards, and actually this can destroy your data center altogether, together with the power supply. And there's personal safety issues, of course. People working in there, they wanted to return home the same way they came to work, and it shows right here. So you see the operator working on a high power supply that has had issues with corrosion, and it's actually the copper lines that are about as thick as my thumb have been corroded. There's conductive copper sulfide being dropped on the ground, and this is what happens. This is well documented throughout a lot of industries, but if you think about what power consumption data centers have these days, we're talking about the largest ones now being something up in the range of 400 megawatts. This is just a little power supply. If you look at a paper mill, at a refinery, this would be something, a distribution of maybe 10 megawatts. So the larger ones, the risk of fires, the risk of total destruction is really high. Well, why is this an issue? basically, we're looking at, there are ways that this has been described in the paper, how to operate a data center. It's in every warranty statement of every hardware manufacturer. It doesn't matter, AMD, Dell, you name them, it doesn't really matter. They say you need an ISO class 8 clean room, which isn't a clean room. I've worked 25 years in the manufacturing of semiconductors, so that isn't a clean room. That's an assembly room at best. But it keeps you mostly dust-free, so the black dust on top of the print circuit boards is not generated by dust that you pull in from air. It's generated by corrosion. And number two is chemistry. You need to keep your room protected by chemical filters. And this is absolutely ignored by everybody. Although it's in the warranty statements, you will not get any warranty replacements. Your insurance won't pay. Nothing happens if you don't apply these chemical filters. It's totally ignored by everybody, even by the insurances, which I'm about to educate now. It's very interesting. They are very surprised to see that. And because there's more and more damage claims coming up, and the hardware manufacturers themselves, the salespeople, don't know that. And because they're always under the pressure to give free of charge replacement of damaged hardware. Yeah. A lot. Really a lot. So this has been described, as I said. There are, actually as a mirror of your clean room, of your data center, hardware, it's mandatory to place copper silver coupons and replace them every 30 days, have them measured in a laboratory, and actually say, to look at, am I safe to operate this? Or am I already at a corrosion level that kills my hardware, that kills my power supplies, everything? So, and actually you can save a lot of insurance if you report this, and it's your insurance fees go down from the 6 to the 7-digit numbers per year. So this pays in itself within a few weeks. So that's the fun part. The OEMs requiring this, the list includes AMD, Cisco. I mean, you can read them. There's basically the who is who in semiconductor and in data center hardware suppliers, semiconductor manufacturers. Actually, I have to rush this. I'm sorry. This is usually a 30 to 40 minutes presentation. So this is just an excerpt, just to show Cisco, for instance, is basically requiring this. This is a 140-page warranty statement of Cisco, and this is just copied from that. And you can take whoever you want, Dell, HP, IBM, it doesn't matter. They all have this statement in there. So if you ignore it, you ignore not to get reimbursed if there's damages, or you have issues because if your hardware goes down, you face, even with redundancy, if you have a fire, if your servers go down, even in redundancy both ways, then you have issues, massive issues. So what are the gases and where are they coming from? If you look at the gases, I don't know how much you liked chemistry back in school. I'm a chemist, so that's, and I specialized in material science and corrosion. So ammonia is basically everywhere. Fertilizers, farming, breeding, whatever. Nitrogen dioxide, you know that from NOx. It's basically everywhere where you have traffic, where you have heating. Sulfur dioxide, sulfur trioxide, anywhere you burn diesel fuel, it's the same. Chloride compounds, close to seawater, but also close to wastewater treatment plants, chemical plants, wherever. Hydrogen sulfide, anywhere. Hydrogen sulfide is a decomposition gas where actually you have proteins decomposing. That means really everywhere you have hydrogen sulfide, specifically in manure, farming, breeding. This is what I say. If you have biogas manufacturing, Germany, for instance, imports 4 billion euros worth of manure only from the Netherlands to process to biogas. And this manure, once it's processed, is extremely sulfur rich from the bacteria that you have inside. And what does the farmer do? They go, put it on trailers and spread it onto the fields, basically surrounding. If you have a nice hyperscaler and you place it somewhere in the countryside, boom, here you go. Excellent. Here's your corrosion. This is what turns copper and silver black. Organic acids, again, your manure, okay? So the question is, okay, so do I just have to watch this and basically my data center goes down, and is there nothing I can do? Actually not. It's easy. Number one is you need to test the air quality. And that means every time, all the time, for the lifetime of your data center, everywhere you have critical operations, you need to mirror your basically the rooms where there's critical equipment, electrical equipment, power supplies, and then you basically go into the point and say, okay, I have to replace or add to the particle filters that I need for my clean room performance. I just need to add some simple chemical filters. And the chemical filters are basically simple, known, since decades operating filters that are not just activated carbon, as a lot of people say. These have to be chemically impregnated filters that form a chemical reaction and solidify whatever gas you have onto their surface, so that you basically take out the pollutant and make it chemically totally irreactive. So this is the key point to that. And that means you usually, even with the continuous testing, you need pre-filters to protect the activated carbon from dust. You go with specific filters for alkaline impregnation, with acidic impregnation to remove, for instance, ammonia and similar compounds. And then in order to prevent the carbon dust to go into your room air, you need a post filter. That actually looks, and we have this on our booth, as simple as that. It's just a V-bank filter. That's all this rolled in one. So you can just put this in there, and we have this as filters with clean room performance, where you have VOC, amine, acid functionality. So you can see there's the combined systems where you can take out the chemicals that come in from the outside air, the compounds that attack. So actually, I'm getting a sign. There's 2 minutes left for me. Any questions, maybe? The cost. That depends on the systems. It's how polluted your air is, how often you have polluted air. That can be from replacing a simple V-bank filter, a few €100, down to the point of where you have to invest in an industrial installation that can be, including a new housing and stuff, that can be a few thousand. But then we're talking about heavily polluted things like, for instance, refineries, tire manufacturings. If you have pulp and paper mills, chemical facilities, wastewater plants. These are the ones that have to really heavily invest, because then you generate tons of pollutants on site, very close to your electrical installations. If you just have something that is there maybe just for the fertilization period of a field, you need to have heavy filters, but only for a certain period in your year. So that's different, but this is to be discussed per installation, more or less. I think, am I done? Oh yeah, okay. So we can, you're welcome to discuss this with me in person. I'll be at the Mann and Hummel booth, or I'll be down here for questions. So I guess we're up for the next. So I'll just run this through.